All right, in this video, we're going to be talking about area models, especially area models that deal with probability. So let's get started. All right, so what we have here is a rectangle that's been cut up into four sections. The following diagram represents a game at a fair. In order to win a prize, a player must flip, and it must be land. Okay, I'm assuming that's a coin that has to be flipped, not the player itself, themselves. All right. Now, the thing about this area model, and that is it's drawn to scale. Okay, so it is drawn to scale. So the first thing we're dealing with is area. All right, so in this example here, area, you are dealing with a whole bunch of rectangles that have the same or that have dimensions. All right, so like for example, what we need to do is find the area. So 15 by 50 area 1 would be 150 uh, square units. I'm just going to go ahead and put 150. Area 2 would be a 15 by 30, which I believe is 450. Area 3, it would be 100, and then area 4, which would be, looks like it'd be 300 square inches. Now you might be asking, where am I getting this information? All I'm doing is multiplying length times width. All right, that's all I'm doing is length times width. Now remember, with this particular area model, 15, 15 feet or 15, I'm sorry, 15 inches, it would be 15 over here on this side. So that's, 30 by 15. This right here would be 30 inches, and then this over here would be 10 inches. So just, just following the dimensions from the other side. Now, it says, what is the probability on landing on section one? All right, well, section one, when you're dealing with probability, basically, this is the kind of relationship that you're dealing with. What do you want divided by the total? Okay, so what I want is section one. So section one is 150 square inches, but the total, so the total of this whole thing, I believe, is 1,000. And yes, it is. So what's the probability? It'd be 150 divided by 1,000, which would be 15%. Okay? Now, what is the probability of not landing on section 4? Well, not landing on section 4 means landing on section 1 is okay, 2 is okay, 3 is okay. So when I add all that up, it ends up being 700. That's what I want, is 700 square inches divided by the total, which is 1,000. So when you do the math, you convert it, it is 70%. All right? Okay, now this area model is a little more challenging because it doesn't give you the dimensions. So like on the last area model, I said, hey, the width and height of each area or of each section is given, but here it's not. Now this is what I recommend, and this is what's going to really make life a lot easier, and that is start with the smallest section. All right, so let me go ahead and write this, and that is start with the smallest section. It'd be nice if I spelled it right. All right, so this is where you do not have dimensions. So what I mean by start with the smallest section, and let's say if I went ahead and assigned, this is a small section, and remember everything is proportionate. Let's say that area is a 2. Okay, so the area of that small section would be a 2. Well, from here, you would know that, okay, well, this has got to be a 2 because that's the same size. Well, that's a 2. That's the same size. That's a 2. All right, so all the little sections um, are the same size. But notice here, and that is the size of these two put together are exactly the size of this one. So that would make this a 4 because they're the same size. Two twos equal 4. Okay. And so basically what's happening is we're just assigning dimensions, or not dimensions, but areas to the smallest ones, and we're just building from there. All right. So which would make that's got to be a 4. That would 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 be a 4. Okay. All right. Let's keep building. Okay. Well, again, observe the size of this rectangle makes up the size of these three rectangles added together. So when you do the math, this rectangle would be 8, which makes this rectangle an 8. Okay. Now look at the big rectangle. Okay. Now again, this is pretty self-explanatory, but I'm just going to go ahead and do it anyway. All right, the size of this rectangle right here, there we go, is equal to the size of all these rectangles added together over here. So they're the same size. So when I add all that up, I believe that ends up being 16. So what I did was I went ahead and put dimensions, or I went ahead and made the areas of all my rectangles. Now, what is the probability of winning a candy cane? Remember, when you are doing probability, it's what do you want divided by the total. All right. So what I want is a candy cane. So I'm going to go ahead and go through all these rectangles. Okay, that's a candy cane rectangle. That one is, that one is, that one is, and that one is. All right, so I'm just going to add all that up. So 16, I believe that ends up being 28. So what I want, 28 represents what I want divided by the total. Let's see, the total ends up being, when I add all the pieces up, it gives me 64. So 28 divided by 64 will give me 43.8%. Now, if 200 people play the game, how many people will not win a candy cane? Will not win a candy cane. Okay? So, when we're talking about not winning a candy cane, again, many different ways to do this. The simplest, not necessarily the easiest way, but the simplest way is to add up all the pieces that do not have a candy cane in it. So I'm going to add all this up. All right, so when I add all those numbers up, I end up with 36. So it will be 36 divided by 64. And I'm going to get a percentage. It'll be 56.25%. But since we're looking for people, I'm going to times that by 200. And so when I do that, the percentage times by 200, 113 people will not win a candy cane going through that example. All right. Now, this is another area model. And so this area model here is given, we're given the dimensions. So, I mean, depending on how you want to do this, I'm just going to go ahead and write the dimensions on here. And so, like, for example, the bottom, that would be 30. This would be 70, because all I'm doing is I'm just, from here to here is 30, from there to there is 70. That's all I'm doing. And just going around the horn. Let's see. This goes 30, which would make this 70. This right here would be 70. This right here would be 30. And I'm just using the scale to get all my information, which would make this a 30. There you go. And then after this, I'm going to go ahead and multiply width times height to go ahead and get my areas. For the both would be 900. For this to be 2100. For the no only, 2100. And then the neither would be 4900. Okay. All right. There we go. Now, from here, we are converting all of our information to a Venn diagram. Now, if you remember a Venn diagram from the previous videos, the Venn diagram, you need four numbers. And what's nice is that you have four sections in this area model. So very simply, what we're going to do is we're going to just start multiplying, and like whatever we get for the both section goes there. The yes only section will go there. The neither section will go right there, and then the no only will go right there. Okay? So that's what we're doing. So let's get some of these. All right, so let's just go and do the both section. The both section makes up 900 square units, and we're converting things to what? We're converting things to actual people. So we have 900 people. All right, there's the bell, but we're just going to keep going. So there's two steps you need to do. The first thing you need to do is you need to find the percentage. Okay? The next thing you need to do is multiply by 900 in this example, or I don't want to put, there's too many 900s in this, multiply by the people. All right, so for the both section, I'm just going to write this off to the side here. The both section, remember, what I want divided by the total. All right, so what I want divided by the total, the both section is 900 divided by 10,000, because that's the whole unit, okay? And then I'm going to multiply this, and I'm kind of writing all over here. Then I'm going to times it by the people, so times by the people. All right, so 900 divided by 10,000, and I'm going to times that by 900, which comes out to be 81 people. So 81 people in this example will be the both situation. All right. Now, let's look at yes only. Okay. Now, yes only is 2100. Okay. So again, off to the side. Okay, I got to do 2100 divided by 10,000. It equals 21%. And then I'm just going to times that by the number of people in this game. 0.21 times 900. That gives me 189. Okay. And what you do is you will continue this whole setup for the no only section as well as the neither section. So no only and neither section, you would just repeat it. And the no only ends up being 189 people, and the neither section is the biggest, which means it has the biggest number of people. All right. Now, we're going to go ahead, I'm going to go ahead and do question number one again, or I'm sorry, going to do question number one, then I'm going to call it, okay? So what we have is an area model where we do not have any, um, we don't have any dimensions on this thing, so we're going to have to make some. So the smallest ones are right here on the bottom here. So these are where you have the smallest pieces. So I'm just going to choose one of them, all right? So I'm just going to go ahead and choose any, mini, miny. All right, I'm just going to go ahead and choose this one. This is what I'm going to use. This is the smallest piece that I'm going to use to build my area model. So I'm going to choose that, and I'm just going to say 2. So I'm going to make this a 2, which means this A would have to be a 2, which means this B would have to be a 2, which means this A has to be a 2. Okay? Now, if A and B down here, if down here they both equal 2, then that means this B would be a 4, which means this A will be a 4. Okay? So you can kind of look at it where, like each row, if you add up all the numbers on the row, you notice that it equals 8 square units. Again, looking at row 2, and I'm just going to do this as well, this also equals 8 square units. So what that means is this top row has to equal 8 units. Well, this top row has been divided into 3 sections. So that means our numbers are going to be a little funky because of the fact that we're going to have to divide 8 by 3. Well, 8 by 3 ends up being, I think, 2.67, I think. 8 divided by 3. Yep. 2.67, or really, I guess we can say 2.66. 2.66, 2.66. All right. So there are all of our dimensions, or not dimensions, but those are all of our areas. So it says, what is the probability of A? Okay, all right, so it's asking what is probability of A, so I'm going to go through, that's an A, that's an A, that's an A, and that's an A. Remember, when we're dealing with probability, it's what I want divided by the total, okay? So what I want are all those A's, so I believe that ends up being 10.66 divided by, let's see, so let's see, 2.66 plus 4 plus 4. All right, yep, that's 10.66. So 10.66. I'm going to divide that by the total of everything, which ends up being 24, I believe. So 10.66 divided by 24, and I get an area of 44.4%. There you go. All right. So hopefully you enjoyed this video. I appreciate you watching. Let me know if you have any questions. Thank you.